We will do a brief discussion about the activated sludge treatment pilot plant. So we have a variety of names. You can call it sewage sludge treatment pilot plant. You can call it activated sludge sewage treatment pilot plant. Okay, and you can also call this as aerobic sludge treatment pilot plant. Okay. So now our basic concern about this device is the basic. What are we going to learn today? So the first of all objective or the motto of the experiment today is how do we characterize the water or the wastewater coming from the main source that will go to the or that will penetrate or that will enter the aeration tank. Okay, so which is basically the big one, which has a stirrer and which has the dissolved oxygen probes, the temperature probes and the pH probes inserted above the, you can see this level. Okay, it's basically submerging to the water level, not beneath the tank but above. Okay, and the second objective is how this system is efficient in treatment of the wastewater. So basically it is going to remove the BOD, COD, nitrate, nitrite, total nitrogen, phosphate, and ammonia at fixed condition. The word fixed condition means what are the influences or what are the constraints or what are the parameters on which the system is going to work. What are we going to fix? We're going to fix the temperature, we're going to fix the pH here. Okay, we're going to fix the stirring speed or the airflow. Okay, or the sludge recycling rate. Okay, now the third part is the effect of pH. Okay, the influence of pH and temperature on the recital performance of the activated sludge system or the sewage sludge system. Okay, so the water basically is going to, the influent or the water is basically going to enter the aeration tank or the main reactor tank. Okay, and from here the treated water will enter the secondary clarifier, or you can say the secondary sedimentation tank, where a portion of the sludge will be recycled back to the primary sedimentation, or you can say the primary reactor or the aeration reactor, and a portion of sludge will be wasted. So that is called basically the excess sludge. Okay, and the effluent basically is collected. This is the outward. Okay, where at the back we have a water, disinfectant, which is a tank which is filled with disinfectant. Okay, where we put basically sodium hypochlorite. So here we will get the treated water, and this is the metering pumps from which fixed dosage of the disinfectant is being pumped to the treated water. So basically at the outlet we will be receiving the water which will not have any microorganism, or you can say the least microorganisms as compared to the raw water which is in the reactor tank, and also the water which is collected in the secondary clarifier. And this one is basically to store the water and to pump the water with the help of the pump to the reactor tank. Okay, now there are certain theory what is activated sludge pilot plant. So it basically comprises of an oxidation reactor, or you can say the aeration tank, okay, and also it consists of a settler tank, which is a secondary clarifier, chlorination tank where we keep the sodium hypochlorite or disinfectant. Okay, and it can also be called as a single stage sewage treatment pilot plant or process. And the substrate BOD is basically oxidized in the reactor here with the agitator by the air blown by a compressor. Basically the air is blown by the help of a compressor, and at the bottom there is a diffuse aerator. Okay, the process liquid is sent to basically to the secondary sedimentation tank through an overflow. So the water is overflowing from here, so it will go from here to the secondary clarifier, and the sludge setters or the settler bottom are basically recycled by a recycle pump. Okay, so that is why basically we say that a portion of sludge is being sent to the aeration tank or reactor tank here. Okay, that is why we say that a portion of, still there is a portion of activated, that's why we say activated sludge, because still there is a portion of activated microbes which is in the secondary clarifier, which is being sent back to the from the recirculation pump into the oxidation or aeration tank. The water flowing out of the settler is basically, I told you earlier, that it is chlorinated, or it's being added by a disinfecting agent, and then is converted to a drain from where you can collect the treated water. Now the biological systems are basically dynamic systems that they permit the removal of biodegradable organic content present in the sewage. Okay, and the sewage treatment basically here is a mixed microbial fermentation of the substrate that is to be removed, which often consists in a homogeneous mixture of components and also of the microorganisms connected to the process, which are mainly mixed colonies of different kinds of bacteria like saprophyte, which break down the decaying organic matter. Basically the BOD or the organic matter present in the water is converted into CO2 and H2O. Okay, and like the biochemical reaction, so we know that this is an aerobic reaction. So an anaerobic zone and mineralization part of the substrate is rarely possible. Okay, which the production of gaseous matter. So basically here any matter which is having carbon or oxygen, so it will be the production of gaseous material from the catabolism reaction, which is called CO2, H2S, N2, H2, methane and H2. So if there is no enough amount of O2 in the reactor tank, then the anaerobic degradation might happen. Okay, there is no enough DO. So that's why we say that minimum the amount of DO in the water should be around 2 ppm. Okay, and the substrate basically in the aeration tank is transformed into CO2, H2O, sludge, and the remaining is the BOD. Now, the efficiency and size of the biological clarification system basically depends on three factors: how the speed of the biological reaction is occurring, that is called the that is the first order reaction; the bacteriological biomass in the process, which is the amount of the microbial mass in the system, and that is in the form of the MLSS; the contact time, that is the hydraulic retention time, that is around 6 to 8 hours between the solid substrate and the bacteriological biomass. Okay, and the solid retention time is completely analogous to HRT. Okay, so HRT is the hydraulic retention time and SRT is solids retention time. Usually the HRT is in the order of hours and SRT is in the order of days. So achieve this, the microorganisms are recycled from the clarifier over and over again. Okay, now we will be basically our main concern is to understand how we carry out the tryouts. There are a lot of theory and you can read books like Metcalfe Eddy and your manuals. So basically the fundamentals is the activated sludge system essentially consists of the aeration tank, okay, followed by a particle separator. In the aeration tank we have a raw sewage, okay, which mixes the group of flocculent solids. Solids contain high amount of bacteria, okay, you can see the theory here, and in the state of liquid sludge inside with a lot of microorganisms, primarily bacteria, live, feed and reproduce themselves to remove the organic substance of the sewage. At the same time, the absorption and bioflocculation occur in the mixture so that the colloidal, okay, and suspended substance in the sewage are also removed by the action of activated sludge. The resulting mixture composed by treated sewage, okay, plus the activated sludge that is coming from the aeration tank passes into the settling tank, in which the treated sewage sludge, which is on the surface, is separated by gravity. So here basically this sludge is separated by the gravity, which is like a, you can say, a tapered shape here, and that eventually will settle at the bottom here. Okay, now the part of the glass is pumped back again to the aeration tank to create enough bacteriological colonies if there is no enough biomass, and the other small part, which is the one which is constantly increasing quantity, that is the waste sludge, which is removed from the system for the finalization, in which you can use the sludges in the form of manure or other, efficient forms, the way we want to use. So as a conclusion, we can say that the raw sewage contaminated by organic substance with limited concentration of is generally not over 0.3 to 1 gram per liter of COD or POD5 is sent to the activated sludge system, and a sludge solution concentrated in organic substance is extracted from the septic tank, that is around 5 to 30 gram per liter, and this must be treated other times before sent to the to the final clarifier or the secondary clarifier. Now let's go to the system here. So here you can see in our case, we already discussed about these return activated sludge and all. So the influent wastewater is usually monitored for, the parameters that we have to look on. Okay, the water which is coming to the aeration tank, so we have to find out the BOD, pH, alkalinity, flow rate, and toxic substances. Okay, and we can also find out the dissolved oxygen, the MLSS, the MLSS, the SVI, sludge volume index, slash density index. You can follow my channel to look about these parameters, how to find out in the labs, or I've discussed in detail how to find out these parameters. Okay, now we talked about these. So we have the process control, data acquisition, supervision. So these are automatically carried by a microprocess control and by a specific control and a supervision software. Okay, and we talked about the activated sludge plant and the incoming wastewater synthetic characterization of the water, and also the BOD testing. You have to do it at the beginning and the outlet, and the water quality parameters. Of course, you have to carry out all the water quality parameters. Now, before starting the device, what you have to look on is to connect the plant to the mains. Okay, through a plug. This is the main control unit here. So this should be connected to the main unit, and then we have to check all its components, like this is for the reactor and this is for the D1, D2, 3 are the pumps and the pipes, and the air diffuser should be assembled in the oxide, and they should be perfectly clean before starting of the device. After connecting, we have to make sure that we are pumping the air through an air compressor, and the pressure should be around 1.5 bar, and also the differential switch should be automatically connected, and then we have to turn the selector, which is the main automatic switch, and then we have to make sure that our reactor tank is fed with the water that is coming from the treatment plant, and that should have enough feeding of 500 gram of COD. If necessary, we can add the nutrients, that is in the form of nitrogen and phosphorus, so that we should have enough amount of COD. Okay, now we have to check these valves are closed. So these valves they are connected at the down, so make sure these valves are closed. Now after that, we have to open these valves, and then we have to fill the reactor with the water up to 10 centimeter under the settler conduction pipe. In this phase, COD of the wastewater must be around 1000. Okay, and then we have to turn on switch of the motor, and then we have to switch on the agitator, which is here, this is our agitator, and this is connected with the main switch. So to make sure it is turned at 1. So 0 is for closing, and at M1 it will start. And then we have to add the activated sludge in the reactor. So make sure we add all these. Now the temperature should be, the minimum is 15 and the maximum is 30. And also make sure that we have added the disinfecting agent. I told you earlier that it is somewhere here. between the reactor tank and between the secondary clarifier or secondary settling tank. And then we have to also fill the settler D2 and D3 with water and connect the tank of the water to be treated to the pump G1. And then we have to also make sure the electrodes that is used for measuring the pH, dissolved oxygen, their covers are removed so that they are able to show the value on the name monitor. Okay, now running of the pilot plant, we have to make sure not only about the COD, also make sure that the dissolved oxygen should be around 2 ppm, which is less than 2 ppm. The process will not be sustainable. Okay, if there is enough, then there are chances that there may be anaerobic degradation instead of aerobic degradation. Okay, and then we have to also adjust the pneumatic valve mount and the compressor tank with the potentiometer to maintain the concentration of O2 is near around 2 ppm. And make sure we are providing the airflow from the external source using the compressor. So the airflow rate should be around 500 to 700 liters per hour, and start feeding the pump G1 and fix the flow rate, turning the proper potentiometer. So make sure also that the COD is also balanced, not only the dissolved oxygen is balanced. Now when the water flow from the reactor will settle to the connection pipe, start recycling pump. Also, if you start the recycling pump, okay, and fix the flow rate. Turn the potentiometer to turning the proper potentiometer, and the flow rate for this one should be around 50 liters per hour. And then we have to start the pump G3 and also start to feed the doses of sodium hypochlorite using the V3 pumps. So it should be 0 is for close and 1 is for switching on. And we can also adjust the flow rate from 0 to 1, and then we have to extract the sample from the outlet of D3 and carry out the analysis of COD or the BOD. And these are the values recommended for right operation of the plant. And the pH, basically the pH in the reactor should be around 7 to 7.5, and O2 I told you earlier should be around 0.5 to 2, and the COD at the outlet, so at the beginning it is around 1000, so at the outlet it should be around 150 ppm. And for stopping of the pilot plant, we make sure that after the plant has run, we have to stop the pump G1, pump G2, G3, and the compressor P1, then stop the agitator. These are the sequence in which we have to close our device, and these are the variables that we need to find out, and then we can compare between the raw water influent and the treated water, which is collected from the secondary clarifier. So these are the parameters: BOD or COD, dissolved oxygen, nitrate, TSS or MLSS. So basically TSS and MLSS are both same things, and nitrite, pH, ammonia, phosphate, conductivity. And then we can make a bar diagram to compare between the raw water, what is being removed, or we can also make a table like efficiency of the BOD removed, efficiency of the dissolved oxygen, efficiency of the nitrate, and ammonia, phosphate, okay, and conductivity and pressure, so that we know how capable or how efficient our system. These are the discussion questions we need to answer in our lab reports. What is the purpose? What does the activated sludge process serve within the wastewater treatment? Why this sludge is called activated? So we already talked about it. Okay. Second question is why air is added to the aeration tank, and what are the factors that are going to influence the amount of air required in an aeration tank? Okay. Now also we need to comment on the results that we got from the laboratory. The tryouts that we did in the lab, and also we need to explain this with a proper graph. Okay. Proper graph means students that we need to make a plot and then we need to comment. Okay. Why this parameter is coming at the increment is higher, why we are getting the lower. Okay. Is our system efficient or is not efficient? Okay. Now this was all about the activated sludge process. I hope you all got what we did in the laboratory, what we did in the lab. Okay. So just watch it carefully. Okay. Don't forget to like and subscribe. Thanks.